Hello everybody, it's Tiana here with my presentation for my midterm project for CIS 9467. For my project, I chose to create a spreadsheet that would nicely put together the data from the New York City tree census. For some context, since 1995, volunteers have taken part every 10 years in counting and cataloging all of the trees in New York City. For my project, I thought it would be fun to look at the data from the tree census, specifically from my neighborhood of Forest Hills, Queens. My aim was really to be able to take a look at not only how the story of the trees in Forest Hills has developed since the census began in 1995, but to also have a way of easily incorporating new data from the censuses that happen in the future. All of my data for this comes from NYC Open Data, where I was able to download full census spreadsheets as well as data dictionaries for 95, 2005, and 2015. I then filtered out the data from Forest Hills and began. Because the census has actually changed slightly in the way that things are classified each time it was run, a large part of setting up my spreadsheet involved some data manipulation and standardization. For example, the way that the tree species was written was different each time. So for example, in 1995 here we've got our Latin names, the common names, which you can see are this kind of broad group, comma, subgroup. 2005, it's here we go, largely the same. But in 2015, all of a sudden, we've switched into kind of normal English. So what I did was just make this tree species spreadsheet, which put everything together, just the list of the Latin names in alphabetical order deduped with their corresponding species names and group names. The other thing that was messed up or different each time was the status of the trees. In each year, different variables were used. As you can see here, different classification systems for the health or status of a tree were used. In 2015, actually here, there were two different variables that categorized this. So it was all a little bit confusing, not helpful. So I just came up with this pretty basic but easy to use and understand classification system. Then to put it all together, I went back into the original data, used some if statements and VLOOKUPs, as you can see here, to work out what should actually be used for my dashboard. So here with the species names, we're just using VLOOKUPs to figure out, okay, we've got this Latin name, what am I calling it? What's the group? Here with the status, it's just a series of if statements. So in 1995, if a tree was labeled as excellent, then we're calling it good. If it was good, we're calling it fair, etc., etc. for each year. Again, you can see 2005, same situation, 2015 as well. Then once everything was standardized, I was able to put it all together. So let's just see what we've got. In the full data set, this lists all the data for all the trees in all 3 years of Forest Hills. We've got the year. The date is just a longer version of the year. Tree ID, I just gave every tree basically a record number. Tree diameter is in inches. It was measured by the volunteers who were taking the census. Just their breast height, tape measure, go around, figure out the circumference, work out the diameter, good to go. Status, this is what I was just talking about. Latin name, common name, the overall group. And then here we have address and location information. So the first part of my dashboard is actually a map using Power Map. So if we launch it, we can see my Power Map. Got 3 scenes here. The first one is the most basic. It just shows the distribution of tree count over the neighborhood. As you can see and guess, I'm sure, the taller the bar, the more trees there are at a given location. So here on 102nd Street, we've got 54 trees. But then over here, let's see, on Lubette Street, there's only 2 in front of 7022. So if we press play, we can see how it changes over time. You can see that a bunch popped up in the middle there. We've also got average diameter. So here, actually, the wider the circle, the wider the tree. Here's a little skinny guy, 5 inches. He must be new. And then over here, we've got some big ones, 27.7 inches. That's pretty big. Again, you can see it over time. I would just like to point out that I think that the reason that there's not much map data in 1995 is I think that there just wasn't enough data being collected properly at the beginning. Hopefully it will be better going forward. Finally, we've got tree health. This just shows the health of the trees at every location. So you can see the red ones are poor. So over here we've got a lot of work that needs to be done. Looks like we've got 19 poor guys over here. A good amount of green in the middle here, and then some fair ones, which, you know, maybe they need some more water. But again, we can see this over time. The interesting thing to note is actually that between 2005 and 2015, I think in 2010, there was a microburst, sort of mini tornado. So that might explain as well why, you know, now we've got a lot more green here. Things had to be replanted. A lot of trees were knocked down. So that is pretty interesting to sort of see in the data. Moving back to the spreadsheet, to create my dashboard, I really wanted to, as I mentioned, be able to not only look at the past, but be able to use this in the future. So with the power map as well and pivot tables, all I'd have to do in the future in 2025 is just standardize my data, add it to the full data spreadsheet, and then just refresh the pivot tables, refresh the map, and everything will update. So I've got a couple different ones here. Then we can see in the dashboard, let's clear everything, that we've got a couple things being shown here. First is the total number of trees and a little spark trend line to show how things have changed. We've got tree status, a little pie chart, good, fair, poor, etc. Average tree diameter, this shows for all 3 years. Tree by species group and subspecies, these each show the top 10. So, you know, this is great and all, but when we've got all 3 years selected, it doesn't really mean anything. So let's just look 1 year at a time. If we look at all 3, you know, trees die, they plant new ones, things are double counted, it's not really worth much. So let's start with 1995. So we can see there were a lot of fair ones, a couple good ones. Looks like the most common tree was maple, then plane tree. The top subspecies here, Callery, pear, cherry, honey locust. If we want to drill down further, we can. We can look at, for example, birch. It looks like all of the birch trees in 1995 were fair. That's good. Birch general seems to have been the widest variety. We've also got river birch, 20% of them here. I don't know if you noticed also, but the average tree diameter updated. So this would be your average tree diameter of birches over time. And the total number of trees updated as well. So this shows the number of birches year over year. The spark line also updated. If we, just for fun, look at 2005, all of a sudden it looks like some got healthy or maybe some more were planted. Yep, we can confirm that here. Again, sort of similar distribution of the subspecies. Moving on to 2015, some were poor, but it does look like there were, you know, difference of 10 here. So some might have died or, you know, just it looks like they're not doing so well. Again, large proportion of the general birch. We can also look at elms if we wanted to. Here it looks pretty straight in terms of diameter. So, you know, we can look at a bunch of different things. If we pick something like magnolia, there's only 2 types. You know, maybe it's not that exciting. We can select more than one. Throw in a mimosa for funsies. Not that exciting either. But you see that we can look at a bunch of different things. Weeping willow is my personal favorite. They've grown, all 2 of them. I don't know what happened in 2005, but, you know, seems like we're picking it back up. So I think, you know, this is just a really fun way to be able to look at trees. I love trees. Trees are great for the environment. They're great for the neighborhood. I hope that we get more trees over the years. I'm excited to see what happens in the next tree census. You know, I hope that we get more data to make that map look more green, get those trees bigger, and we'll see what happens. Thanks.